All right. So these terms here, encephalization, prognatism, endocast, platycephalic, sagittal crest, position of foramen magnum, postorbital constriction, and megadont. Let's look and see how they relate specifically to two fundamental groups of early hominins. First group of early hominins will be on page 1 of your hominin review sheet. The very early and also the hominins that are known as gracile. The other group will be page 2 of your hominin review sheet. And on page 2 of the hominin review sheet, you have a couple of sentences there at the top that say that grouping, and there are only 3 species on that page, that grouping is known as the robust Australopiths. Some specialists might think of renaming them from genus Australopithecus to Paranthropus. That's really well explained in your chapter. We want to have this be also visual for us. So let's move forward. Also in that, towards the end of the chapter, they start talking about probably the most famous fossil hunting zone, Olduvai Gorge, and begin to introduce the concept of tools. But right now we're going to look at anatomy first. So those core and flake tools from the so-called Oldowan style, which means they come from Olduvai Gorge, and the concept of how did they feed themselves? Scavenging. All right. One more vocabulary term here that goes again, going to come up well to the end of chapter 10, osteodontochoratic. That has to do with tools. We're going to start with anatomy. Okay, so I want to work with you right now on encephalization and the term endocast, prognatism, postorbital constriction. So one more, and the term platycephalic. So I'm going to use my drawing tool over to the side. You can do the same thing. These are going to be like what you want to put onto your class visual activity. So, and drawing with my mouse, always a challenge, but I have practice and I think it's going to work very well. All right. And for right now, I'm just going to work this one. So firstly, let's just do a very basic in profile look at an early hominin cranium. So just the head to begin with. All these terms are relating to cranial anatomy right now. So it's something all of us can do. You all, if I can do it, exactly. Because I do not have super skills. So usually I start and I make myself a nice orbit. And then remember, anything in order primates has a nasal aperture at the opening so that you can breathe. That's just slightly in front of the orbit. So I'm going to go ahead and just make that little one here. Here, this will give us some of our angles. So the only thing joining this right here will be the nasal bone. Now, for what we're looking at in this unit, then I want to actually just make this a little bit rounder here. There we go. Oh, I'm happier with that one. Okay. Personality here. All right. So let's start with the frontal bone. In your ancestors, the frontal bone is not vertical like yours. It angles back. So make it nice and going this way, bring it down around. We're at the occipital now. Stop right about here. Now you want to give it a little bit of contours here So you get a kind of an idea of what's going on. So you want to get the very top of your zygomatic here. Come down this way. Come right up here. All right. Yours can be slightly rounder than this one, but we'll get the angles that we need. Now, give it the ramus of your lower jaw. All right, so we're going to do a jaw here. So here's the mandible on the bottom. Come down, come forward here, keep going, and bring it well in front of the nose, cartoonishly well in front of the nose. Angle it this way. Now bring this down here and here. So again, if your nose, this isn't the best nose I've ever done, but it'll work. So now we want to make a line right here. There's your leg, because they have teeth, and some verticals here for your teeth. Remember, you have 2, 1, 2, 3. So you need to indicate, here's 1 molar, 2 molars, 3 molars, 1 premolar, 2 premolar. You got the canine right here, and we'll see this. So I'm just going to go ahead and square that out a little bit for you. Okay, so this is more or less what we would see, right? Just in very, very basics. So we've got, and I'm going to make this a little bit longer here for myself. No, it's going to be heavier, but make sure again that this here coming out this way. All right, our cheekbone coming this way. Okay, I'm going to switch colors real quickly and to use something that's bright that you can see and that's a little bit narrower. I'm going to go ahead and indicate here, because I think it's going to make it simpler for you, these cranial bones that you learned. Let's do the back end of the frontal. Then we've got the parietal, right? Occipital bone's going to come down this way. And then right about where your ears would be, you've got your temporal, and then this one coming over here, your sphenoid. Okay, that's all you need with that. Back to darker color and then make it a little bit thicker. Okay, so our terms right here. Let's start with this one here, prognatism, P-R-O-G. It sounds like project, and that's a good way to remember this one. So if we take and start here, oh, and I want to do this one so I can make some nice straight lines, so it's tidier now. Start here, go here, now come up this way, here, and I'm going to switch and do a little arrow here. Okay, see how far forward of the forehead the jaw is here on your sketch? Right, so this term, this one here, prognatism, is in reference to the fact that this, do we have one of these that I can do this? Some of these are going to be, I'll go back to this one. So we're going to see this term here is in reference to the fact that, do it like a little bracket here, that this is so much further forward than this up here. So this term refers to this angle. Think of it as a projecting jaw. That's prognatism. All right. Let's try a second term here. We're going to work on platycephalic. So let's make a vertical this way, nice and straight. And then I'm going to do it on a draw. So your forehead, it isn't super vertical, but it's pretty vertical compared to this. But you can see here that the frontal bone is leaning way, way back. So just take a nice little arch here. But this is very low, right? We have a very wide angle here. for this one. This is very low. So the term for this flattened forehead is platy, like plate. And then ceph, we see it here on this one. See it up here also, ceph. Ceph, you all, in this unit and the next one, is always going to refer to the brain box right here. We haven't learned any specific vocabulary for this portion of all these bones together. So let's just use brain box for now, because we had enough to learn on this unit. So ceph, so this is always going to be this back area. So what this is very, oops, I'm going to not do that one. I'm going to write in text. Very platycephalic. So this type of cranial anatomy is very platycephalic. It's also, put it over here on this side, very prognathic. So GNATH, this part refers to the jaw. So some of you have done art classes, not art, art history and mythology. There are beings or sometimes supernaturals that are agnathic, and that means it's a being that doesn't have a lower jaw at all. For that one. So very platycephalic and very prognathic. Okay, so that's platycephalic. That refers to this situation here. Okay, we've got two descriptions, very platycephalic and very prognathic. So post-orbital constriction. Post-orbital constriction is going to refer to, let's see what that one does. I don't know what that does. See if it does this. Post-orbital constriction is going to refer to areas that are squeezed. There's more of a pinching look back here. It's going to be in this zone. So post-orbital constriction down into this zone. It means that the space, the width of the brain box right behind the eye is tightly squeezed. If we look at it from the top, and we'll come back to this and look at it from the top in a little bit for this one. So this is post-orbital constriction. And again, very much post-orbital constriction. All right, so a couple more things right here before we go with this one. So encephalization and endocast. Generally, endo means inside, and you learned in the previous unit that a cast is a type of fossil. So endocast, you all, I'll go ahead and just do text. Endocast fossilized brain. So that's not what I have in the drawing here, but you'll read about them. When we have a fossilized brain, that allows us to be more secure with the concept of cranial capacity, or the volume of the brain. For page 1, the early hominins and early Australopiths, that cranial capacity, so it's going to be, you'll see it as cc's or mLs, milliliters, is going to be just a little bit smaller than the cranial capacity or milliliters, mils, that we see in page 2 in the robusts. So these are going to come in around 450. Oops, let me mic in. These are going to come in about 450. So what would I do on my drawing right now? I'd probably just write that right here. This thicker. And just label it right here in the cranial zone. Okay, so what's that in proportion to the size of your brain? Your brain is probably, unless you're very, very tall and a really robust frame person, that wouldn't be BMI. That would just be, you know, width of the shoulders and how tall you are. You're going to be right around 1,300, 1,350. Some people are bigger, but some people, right, are 6'7". So around 450 for that one. Okay, so what group, which fossils are going to be, let me do a few more little other things here because I'm, are going to be like this. I'm going to actually, I want to make its eyes a little bit more like eyes here. There you go. I haven't practiced with this particular tool, but it's doing it for drawing. And same for the nasal aperture here. So it's just really clear as we wrap up that this is a hole. You're saying, of course I know it's a hole. That's where my nose is. Okay, so we've got the orbits here, no vocabulary for that. Nasal aperture, no vocabulary for that. The teeth, 2, 1, 2, 2, 3, just like yours. They are larger than yours. But we've already looked at that. And so if we're just looking at cranial anatomy, because we did palate shape last time, if we're just looking at cranial anatomy, we're seeing that they have the low forehead. And why is the forehead lower? Because the brain is lower, right? It's only about a quarter, less than a quarter, what we say? It's about, yeah, 20%. My stats are bad because it's first thing in the morning. So let's just say, just learn 450. I'm not going to ask any questions on percentage. Yours is around 1,300, 1,350. Some of you are going to be bigger than that. So if we did this times 3, then we would be that. Now, is 450 cc's or mils really a tiny brain? And the answer is no, not really. It is actually quite significant in relationship to body mass, right? To the overall size of the individual. We're going to come back to that. So in this one. So again, one more time, what are we labeling here? I'll do it in text. I'm going to do bigger and bold. So what is this drawing for, you all? This is for page 1 on the 21, 1 on the hominin review sheet. These will be early hominins and the gracile Australopiths. Gracile Australopiths. Early hominins and the gracile Australopiths. You'll have that part in your reading, but that's in page 1. All of them, you all have the same description. So as you're working on your visual activity and you've got your upper line that's going to be longer, right? Because it's older. That one's going to start at 6 point. Are you looking at your sheet? 6.2 million years ago for Auroran tugenensis, and then go to the youngest, which is going to be just under 2 million years ago. And so you have Auroran, Ardi, then Australopithecus anamensis, Afarensis, Kenyanthropus, and you'll have the Littlefoot fossil, Australopithecus prometheus, we'll have Africanus there, Sediba, right? And then you're going to start with your bullets dropping it down. All of them, the cranial capacity, if we know it, and we don't have that for Auroran, but if we know it for the others, then just write it in once and then just make a line going across all of your species names, right? Why write it out underneath everyone? Everyone on the older, earlier gracile group has got about 450 cc's or mils. All of them are very prognathic, projecting jaw. All of them are very platycephalic. Okay, are we good? All right, I'm going to clear everything. I know. So, early hominin, cranial anatomy, or also known as gracile australopiths. Oops. Need to clear everything and turn this off. All right, let's go to the next one. So, cranial capacity was on that too. So, let's look at a couple that are early or gracile. And this is what you were working on. But again, sketching it yourself is going to be the best way to remember it fast, save you time, and be very accurate when you see some other kinds of questions. So again, just as a couple of little highlights here. So this area up here is very prognathic or very platycephalic. You're thinking prog seems like project, but this is laying flat, flat. So this is a flattened forehead. For this one too, again, see how this is well ahead. Change colors. See how this is well ahead or forward of the forehead. And so for this is projecting. So this is very far forward. We don't really think about this in our species today, right? Our face is very flat. Well, theirs wasn't. Theirs was very long. Why is it longer? Their teeth have a lot more enamel. So they have the same number and shapes of teeth, but their teeth are very heavily enameled. Raw diet. Oh, they're better teeth, no doubt about it. We don't see them cracking up or those sorts of things. So this is extremely prognathic, extremely platycephalic here. If you were going to jot something in and say, what do I know that it's going to be in the right age frame for range for cranial capacity? It'd be 450 for all of them. Some of them are slightly littler, some of them are a little bit bigger. Again, for us, we're getting a general concept of the timeline. Here we can see on this one too that very, very far forward compared to this, and we can also see. Right, this one didn't preserve all of its little teeth here. See that let's do another color for our. And this one, see how dark red this is? That means it's deeper. So it's a lot of post, means behind, cranial constriction. So it's squeezed in because again, the brain is not as large as ours. Ours has flated out, right, or inflated, it's wider than ours. Okay, last one here, thinking about endocast. This you all here is the fully cleaned and removed from the breccia, from the stone that formed around it in fossilization. This is the earliest discovered and recognized hominin fossil ever found scientifically. This is the Tong child. It came from an area called Tong in the Republic of South Africa. So this one started everything in regards to recognizing that bipedality evolved in Africa, and bipedal ancestors are in Africa from more than 6 million years ago to about 2 million years ago only. So for over 4 million years, only human ancestors in Africa. We are an African species. As you're reading, in your text, it talks about how the Tong child fossil originally, Raymond Dart could not see all of it because it was only a little bit showing in the rock. And so he had to clean, and it took at that time a really, really long time to do. When he did, you can see that the frontal bone is preserved, the zygomatic is preserved, the sphenoid is preserved, and maxillomandible, but the parietal bone and the occipital bone and the temporal bone were not preserved. So what is this back here? See all the little lumps and divots and little, right? The little pressure spots in here? That is a fossilized brain. This is an endocast. Now, the Tong child died as a baby, and fascinatingly enough, but not happy for it in its last days, nor its parents and family of its social group, whatever family was at that particular time. The Tong child was grabbed and taken away as food. It was hunted by probably a large raptorial bird. It actually has talon marks that went through the cranial bones and right down in, and lifted it up by the head and flew away from it. Why? Because it weighed very, very little. Would it be a nice piece of game for those larger birds to fly up into a tree and finish. It had some of its deciduous teeth here, so they get a pretty good idea of this. But see again, and the last one, see how we have, I'm going to go over here again to drawing. We can do this in orange as well. And see how we have this angling this way, right? The jaw does not come forward with a bump like yours, so there is no jaw. So do they have that, or not jaw, they have a jaw. They don't have any chin. Do any of them that we're studying this unit have a chin? Nope. We're the only phase that has a chin. So yes, the jaw's here, angles back, but the whole thing comes very far forward here. All right. And so this one we see as well. Same thing, just with more in the pictures this way. All right, clearing everything. All right, next. So let's look at robust Australopithecus, or so-called Paranthropus cranial anatomy. Sagittal crest, megadont, widely flaring zygomatic. We're going to add those three terms to our description, and we're still going to be using prognatism, platycephalic, and of course we want to know cranial capacity. So now drawing this one. So I'm going to go to darker again. You're going to just start in the same way. There's nothing different in this one from the size and orientation that you put with your orbit and your nasal aperture. So hopefully I'll get mine just the way that I want here. All right, nice like that. Try to make it as big as I can. Nasal aperture going to be smaller than the orbit. That'll be good-ish. I think I will do this one slightly a little bit more. Again, all right, give it a nasal bone here. Okay, we're going back to the frontal bone. We're gonna go this way, round, coming around to the back, come underneath. And now the parts that are going to be a little bit different. So we want to, again, do a zygomatic, but the zygomatic, remember your cheek? The zygomatic on page 2, the robust or Paranthropus group, is really large. So just as you do it, make it really big and noticeable compared to your first one. Okay, now let's do the lower jaw. In this one, the same thing. This is going to be really, you want to make it cartoonishly gigantic. compared to what you just drew. Angle up, because if it has a lack of chin, come straight up this way, and then bring that forward. Oh yeah, this one's, I'm warming up now. Do the tooth here, through here. Okay, we got a couple other things to do. Up here on the top of the head, you're gonna make a little bony mohawk. Has to be there or we're not looking at page 2. At the bony mohawk. Here, for Paranthropus or the robust australopiths. Robust doesn't refer to postcranial. The body is almost no real difference between the two groups. They really look different in chewing anatomy, which is really well done and clear for you in your reading as well, but working on it together makes it faster and more efficient for you, I think. So here, so I make a big square here for these. And now I'm going to just change color so that it makes a little bit more sense. I'm going to link all of these with the bright green color. So I'm going to make these, right? You got 3 molars. So we've got 1, 2, 3, 4, 5, 6. Those are the molars. So this we're going to link down here, this over to here, and this over to here. We're just going to keep those. They always come together, you all. This bony mohawk that's up here on, right, it starts behind the frontal bone and it'll be down the center of your 2 parietals. Oh, now you know why we learned cranial bones in the 3rd unit before this one. Your zygomatic here, very, very wide and heavy, and megadont molars. If we find a fossil that's got one of these features, it has the other 2, but sometimes they're incomplete as you've been learning. I'm going to go back to working with the orange color that we were using before. So those are going to stay together, and I'm going to do this one for just straight lines. Okay, here, come forward. Now bring the line up. Make the, you can do it faster than me, right? So that you can remember, right, that this is far forward. This is a very heavy jaw right here. I'm going to go to a different color. Let's do them this way. So instead of having an upright, let me undo that one. I want to draw, not arrow. Instead of having a very upright frontal bone, the frontal bone is flattened. So it is platycephalic here. And let's give it the rest of its teeth. We go towards the front. Nothing unusually distinctive about the premolars, the canine, or the incisors here. So just these, just the molars, megadont molars only. So it is, goes faster once we've already done it once, right? It is very prognathic. That's the same for all of them. It is very platycephalic. Same for both groups. Here, cranial capacity. For the fossils that we found, and really for both of these groups, there's a lot of species names and they have a lot of little parts, but they really only have one fossil ever discovered where they have virtually the entire body, right? The little foot, where they've got head, hands, arms, legs, pelvis, all of it. The Lucy is pretty complete, but they don't have the upper head. And the Tom child and the Dakika fossil, they have very complete for the crania, but not really much else. Nothing else for the Tom child. All they found was the head, probably because the rest of it got consumed up and lost after the animal was done with with breakfast, lunch, or dinner for that one. So for this one, and again, if it's really in terms of the actual measurement, not that much difference, but the number does look a little different. So for this one, we're going to do 500 cc's or mils. You'll just put it right here. So when we look at this, this is, and I'm just going to make this a little bit. So this is a upper one here, sagittal crest. We really don't see a noticeable sagittal crest in both males and females, and especially bigger in males, until we really see these that are much younger. And also take a look at your format, your paper right now. These are much, much younger, right? They are under 3 million years old. So these are specialized feeders that evolved later on. We have much earlier, 6.2. Are you looking at your first page? 6.2, 4.4, 4.2, 3.9, 3.5, lots of species in both East and South Africa that are the gracile ones, long before, millions to hundreds of thousands of years before we actually see these specialized hard diet feeders. So this is a sagittal crest. If it's real noticeable in a picture, you're looking at a Paranthropus or robust. This is going to be the widely flaring zygomatic. I'm just going to put zyg right here, and this one down here, megadont molars. The other teeth, not really so much huger. So again, on your activity, where you have now the shorter line, that's only going to have Australopithecus aepiopucus, boisei, and robustus, that's the lower one. Then the drawing that's going to go right next to it for your points on the visual activity is going to be real heavy here. You want to be sure that you've marked and labeled real quickly crest, widely flaring zygomatic, and the megadont molars for these. Otherwise, platycephalic and prognathic, that is similar between both of them. In this case then, their brain is about just a little bit less than half the size of yours. But for some of you with a much, much larger brain, it's about 30% of the size of yours, right? So if yours is closer to 1,500 cc's or mils. Cc's or mils just means, did they make the measurement for solid, or did they make it milliliters, as if the measurement volume, because they're both volume measurements in liquid. So cc's or mils, you'll see either one. So sagittal crest, megadont. In your nicknames, the only nickname fossil that you have for these is Zinj, and that one is the Australopithecus boisei, also sometimes called nutcracker, and that was from the media as well. Okay, what links these three things together? What makes it so that, I'm going to go over here, it's this one, and see if I've got a, what makes it so that these things all combine? Let's try, yeah, I can't do too much with, I guess maybe light blue will probably work. So the thing that links these, why does this evolve and become larger? We know that sagittal crests are present in species that have tremendous chewing strength. So what happens is, this is an anchor point for muscles that are then going to come down into this zone. Let's come across here. They're going to anchor chewing here. Now these muscles, one more, here go underneath the sagittal. So they're going to be coming underneath here and then anchoring to the jaw. And you'll see that, I think they've done it in sort of pink, right? So we're going to have these coming down here, anchoring up here, down, going underneath the zygomatic, and that's the same as it works on you. Your chewing muscles don't go over your cheek, they go under, and then down, attached to here. That gives huge more bite force to grinding in those molars, which is why they have the megadont molars. Okay, so it's all about chewing. I'm going to clear all these and close this. So let's look at some JPEGs of this one. All right, so here's 3 of these. Practice from last week. Let me get in my, what would be brighter? I guess this one will probably do it. All right, practice from last week. Here is this is not a U-shaped, right? It's not a U-shaped dental arch. So this is not hominoid. This is intermediate. See how the center here is coming around and down here. It's not really rounded arch like we have. Also, see here, there is no diastema. No diastema, that's the gap. Then it's going to be hominin. So you know you're looking at a hominin, and this is a little bit wider back here. The bone itself here is incredibly wide on these. And that's because these are those extreme hard diet feeders. So they've just got the biggest, heaviest, strongest mandible and maxilla bones, really. And then these really enormous, do it here, really enormous molars. So for these megadont molars, you can see they're really strong. The teeth are really healthy after a lifetime of chewing. They're chewing foods that are really hard vegetation, nuts, and then the type of grasses that would be more things like you see antelope, buffalo, and those sorts of animals, those big heavy duty chewers that we see on the landscape in that particular region of the world as well. Okay, so if we're looking from the top here, we've got the super, I'll do it white, brighter color is probably helpful, right? So we've got that super, super wide, see that really widely flaring zygomatic arch. Look at how much wider the cheekbones are than the side of the head. For you, our cheekbones are narrower than the side of our head. So they're really, and why is that happening? Because they've got massive, massive chewing capacity, right? These big bones, muscles coming here, going underneath. So really heavy duty for chewing. And then that chewing muscles come down here and anchor all that to the lower jaw. So we're really just going to get lots of musculature, lots and lots. What's a primate that has a really huge, bigger than your ancestors even, sagittal crest? Gorillas. Pure, full-on vegetarians eating really hard foods that they have to really chew, chew, chew. Okay, super widely flaring. The sagittal crest from the front, we're going to see that coming up like this. Sometimes it'll be smaller. Sometimes it'll be more noticeable, but I will only show you images where it's noticeable. Now, sagittal area. The sagittal area is that line in between. So we're looking at it from top down on this one over here, is right where your 2 parietal bones meet. So that is your sagittal area, and here there's a crest. So you have a sagittal area, there's no crest of bone there because you're not a hard diet feeder, especially not anymore for these. See this area here that they've got really dark? This is that very large opening underneath the zygomatic. So that's why this is coming over here so wide, because we've got this big, big space here. And then, so strong post-orbital constriction, right, is going to be, see how pinched it looks? Yours from the top is just round, and then everything meets smoothly there. So you're looking at a robust Australopith, either Australopithecus ethiopicus, robustus, or boisei for those, with the nicknames black skull, zinge, And then really old time ago, they used to call these nutcracker. And in fact, that is part of what they were eating. They were eating these super hard nuts. So for instance, if you had this anatomy here, the sagittal crest, this amount of muscles, these really heavy duty molars and a very, very strong jaw like this with the long hinge, you would be able to get macadamia nuts and crack them with your teeth and snack, or walnuts and crack them with your teeth and snack, or anything else with a heavier shell. I was going to say pistachios, but those aren't that hard. Our teeth can actually do that, sort of, at least. Okay. For that one. Okay. Do I see any questions on this stuff popping up? If you have anything that you're like, oh, that you aren't quite grabbing onto, then just let me know on these. Otherwise, I'm going to stop this right here.